Hello, today we'll try to solve number with people in a queue, which is hard problem. There are people standing in a queue and they number from 0 to n left to right order. You are given an array of heights of distinct integer heights. I represent the heights of each person. Person can see another person to the right. Whoever value is in between is shorter than both of them. More normally, I person can see jet person if I and mean heights more than max heights of next one. Yeah. So if this person is higher, it can see 1, 2, 3 people, but cannot see this one. This person see only one. This person see two, right? Two. This person see only one. This person see only one, and this person seeing zero. So yeah, it looks like monotonic stack problem to me. So what we can do, we can create stack and we can move from back, because if we're moving forward, we are unable to see iterate. So let's say we iterate heights from back. Then we put for every I heights. So the last one is always zero, right? When so we calculate the length of the heights. We assign L minus 1, 0. It always will be 0. Then we iterate heights from the back, and so if starting and also this will also always see one person, right? No matter if it's higher or bigger. So I can say heights L minus 2 is always will be 1. L minus 3, what we're gonna do. So this step minus 1, and we also add we also have to add this to this height to a stack. And no, so we have to declare a result, right? Result equal, I'm sorry, result heights. Oops. and then we add stack minus 2. But we have to take a look if this is smaller, we are not adding. So if heights minus 2, yeah, but we need to add to stack index as well. So what we are adding to stack, we adding list of heights and index. Right? Because if we pop, we have to know that this is or not. Okay, let's see. So this is the last is 9. Next one is 11. So we don't have to add 11 to it. So stack will be 9. So we can say that we add to stack 9 if so the idea is, let's write it. Keep means increasing monotony stack during iteration, and use length of the stack as answer for every result I, right? So if we have this, we have for this we have just one, right? Length of monotonic stack. So I would say that result of I equal length of stack. Then if height of I more than stack 0, what we're gonna do, we go on stack pop, and then because it's more than, it become new. So I would say while, because if different of them, we have to put all of them, right? And then we add heights I Am I writing it right? Correctly. It's I stack push. Yes, and then we return result. So let's see if it will work. Um, so let's have this example and trace it here. So stack will be empty, result will be empty, of course. So we will start from this, right? And we add stack equal stack will be 9, and we move to next one. And len of the stack will be 0. All right. Len of the stack will be 0. This len of the stack will be 1. So we start from here. Len of the stack will be 1. So result will have, oops, result will be 1. And then we move to 11. And like this. If height of the stack is more than what we have in the stack 11, yes, then we pop 9 and we add 11. And then we move to this one and it will be 5. It also will be 1. And if height is not, we add in 5. So it will be 11, 5. We move to 8. And we put 2. 8 is more than 5. Yes, we pop 5 and we add 8. Then we move to 6 and 6 is not. 6 is also 2. Okay, now I see the problem. It should see 6, should see 8 and 11. Should see 8 and 11, but it's not gonna see 11. Okay, now I see the problem. Okay. So it's not gonna see 11, even if looking at the right, 8 will completely. Okay, so yes, this is what happened. So we should consider this. If heights Yep, it's not gonna work. I would say if heights more than stack 0. So from stack we have to find nearest max, right? Because we cannot, for example, if this 2 then 8. So if we switch this, it's still 2 until we find max. So we have to calculate. How about if I define another function and I call it stack wheel, and I will press I, and I will, while for in stack result equals 0, while if stack I if I less than h, result plus 1, else return result. So we will go through the stack and find until we match higher heights at our current. So instead of doing this len stack, right? So this is incorrect. Incorrect. And correct statement will be calculate amount of items in stack less than height speed, right? In this case, we will have just 1, and we add 1 instead of 2. So we will have 1 and this we add, and then we add stack. We add to stack 6, right? 6, and then next one we got 10, and we just calculate heights because 10 is 8, 6, 11. Okay, so this function will return, so it will go 8, 6. I think we have to add 1 because we still see 1, right? And we return. Okay. Okay, let's implement this. I think it should work and that it will return 3. Maybe I should run it again, but I don't have time, so let's try to implement it and see if it works, right? So this function goes here. This goes here. And then iteration part and return part. So iteration for e in range. So how to do reverse. So this is L minus 1, minus 1, minus 1, right? Minus 1, minus 1. So instead of assigning this length, we call stack width. And get okay, everything is good. Let's give it a try. Okay, so I have to initialize lists. I cannot add. Right, and I have 0, 0 multiplied by L. Yeah, I have. It doesn't have a do push. Mm, I think it's a band. in Stand band. Out of range. Okay, so why hides I? Noise and stack line. Why it's out of range? Oh, because probably it's at L minus 2. Is it inside? Wait, where is it? Hides I. Stack. Oh, if stack is empty. If stack is empty, while stack and or I think it's can. So if stack isn't empty, we pop. Oh, no. Incorrect answer. So, okay, we do stack this. Stack this instead if I less than each. Okay. Mhm. So error when we have to have two, which is um, 1, 2, 3, 1, 2, 3, 8. We are starting on 8 and we have to have 5 and 11. So let's see. I want to have age and stack. 5, 11. We have to have answer 2 because for e in stack, if I less than h, no, if I more than h, yep, that's a problem. Then we have problem with 3, which is 6. Now why we have this? Oh, okay, so we append only if whilst append hides all, which is 8, right? Because it's got h. So it shouldn't be, it should pop 5. Why it's not popping 5? Oh, it's okay. Let's add only if age less. No, 11.5 we can add 5, right? This is correct. But we didn't pop here. If age more than stack 0, we should pop, right? Why we didn't pop? Oh, that's a mystery. Oh, I have to compare with -1. Now it's correct. Okay, at least stack is correct now, which is good. And 6 is reporting too, because stack with 6. Stack with 6 has if I in stack. Yeah, so if age more than I, yeah, it's correct. If less than age. Yeah, this is weird. So this is 6, right? Let's go back to 1, 2, 3, 4. So this is 8. Column 8 and 5. So there is a 5 and there is 11. It should be 2. So stack is 11.5. Oh, we have to traverse stack backwards too. Right. So in for I in range of length of the stack -1, -1, -1. It traverses stack backwards. All right, let's try to submit it. Yeah, output limit. Okay, output limit because I'm printing the same. Let's remove print. Right again. Come on. Yay! I'm the last 1.5%. Yeah, there is a probably like there is a space for optimization, and this is obviously given the square complexity. So I wonder how people did it faster. Okay, lens. Also, we keep count. We count in pops. That's interesting. It's very interesting. Okay, that's it for today. Thank you for watching. Bye.